For problem 1, for getting the sum of 482 plus 173, I used the decomposition method. So then 482 becomes 400 plus 80 plus 2, and 173 equals 100 plus 70 plus 3. So the way I wrote it out total is 400 plus 80 plus 2 plus 100 plus 70 plus 3. And then what I did is I added what would be in the ones column, what would be in the tens column, and what would be in the hundreds. So if you see, I grouped it here. So 3 plus 2 equals 5. 80 plus 70 here equals 150. And then 400 plus 100 equals 500. So then I broke it down to 500 plus 150 plus 5. And then I broke this down even further because I feel like it's easier for students when they're learning about the ones and tens and hundreds column to see it broken down even further. So it'd be 500 plus another 100, because that's the 100 here. The 50 goes here, and then the 5 goes here because of plus 5. So then it becomes 500 plus 100 equals 600, and then you know you have 50 in the tens, and then you have 5 in the singles, so then it becomes 600 plus 50 equals 650 plus 5 equals 655. I think the benefits of the decomposition is it simplifies the adding of the numbers to the smallest numbers possible. And you can make, for some students that are visual learners, you can make a chart and break it down. So it'd be the hundreds, the tens, and the singles. So 482 would be like this, because that's the hundreds, the tens, and the singles. And then 173 would be like this, because you have 3 ones, 7 tens, and 100. And then they can do this addition on their hands. So, for example, 3 plus, and then you need 2 more equals 5. And then 8 and 7, you could count to 8. You could count 1, 2, 3, 4, 5, 6, 7, 8, and then keep going. 9, 10, 11, 12, 13, 14, 15. So you can make this 5, and this is 15. And then you know you have an extra 10 hanging over, so you got to carry it over to here. So 4 plus 1 equals 5. Plus you have to, can't forget that 1 that you have from this one. So then that becomes 4, 5, and 6. And that's 6,855. I think breaking it down to the simplest numbers possible makes it easier for kids of different age groups and different grade levels to solve the problem. For the problem of multiplication of 9 times 63, I would use the making adjustments, and for me, I would make this 10 times 63, we know is 630. So for the way that I explain the 10 tables to both of my children, one is in 7th grade and has a hard time with math, and one is in 3rd grade, is I always tell them that 1 times any number is itself. So if you have 1 of 63, you have just the 63, and then you can't forget the 0 because he's got to go with it. So then it becomes 630. It's just the way I explain it to him. So in order to get to 9 times 63, we know that you would have 10 groups of 63. So, and then you would just subtract 1 group of 63. So then the problem becomes 630 minus 63. And a poster that I actually have for one of my sons tells you the rules of, if you have more on the floor, you have to go next door and get 10 more. So I have more on the floor here, so I know that I need to borrow 10 from this, so that becomes a 2. And then I can solve this problem, so 10 minus 3 is 7. And then again, I have more on the floor, so I need to borrow 10 more, so that becomes a 12, and this becomes a 5. And then 12 minus 6 we know is 6. And then 5, and there's nothing here, so we can leave that. And it says, more on top, no need to stop. So because this number is less than this number, there's more on the top, no need to stop. So you know that you can take, and if you have 0, you're not taking anything away, so that just becomes 5. So that's how I would solve that problem. So if you had 10 groups of 63, you would have 630. So if you only want 9 groups of 63, you would subtract 1 group of 10 from the total that you got from the 10 groups of 63, which is 630. So you would take 630 and you would minus 63, which is the 1 extra group of 63 you have, and then you would get 567. I think the benefit of using the making adjustments is making it easier for a kid with times tables that are more comfortable or easier to solve. And also, this is something that with the 10s, you can use Unifix cubes, you could use any form of manipulative really, and you can make the different groups of 63. So you can make that many groups of 63. So you could start off by showing him him or her the 10 groups of 63, and then taking one away, or you could make the 9 groups of 63 and get the answer. But if you're having to do it mentally in your head, without the manipulatives, it's easier when you use groups of 10 for your multiplication, because again, 1 times itself is the number itself, and then you just add the 0. Even if this was 8 times 63, it would still be the same. It wouldn't change the way you solve it. You would still get the 10 groups of 63s minus 630, and then you would take away 2 groups of 63. So you would take away 2 of these. So it would look like 630 minus 63 equals, and then you take another group of 63 away. And then you would get that answer. And again, it would be 7 minus 3, so there's more on top. You don't have to stop. Numbers the same, 0 is the game, so that becomes 0, and then 5, there's nothing, so there's more on top, no need to stop, so it becomes 504. So again, it would be, I feel like it just makes it easier to simplify the problem and make it something that they're more comfortable with, or something that is easier to explain to them to solve the problem.